Good day everyone. Welcome back sa ato course on electromagnetism. So we are now on the topic on the second half of our course that is on magnetostatics. So previously sa electromagnetism 1, so the bulk of our discussion was more on electrostatics because it's a big topic nga i-discuss. Actually, big topic po ng magnetostatics, and we'll just have to see kung tama na itong pwede ma-discuss regarding magnetostatics. Okay? So, magnetostatics is from the word magnet and statics. So we have magnetism and static meaning it's not changing. So what is not changing here is the magnetism nga part, it's the strength or the currents are steady. Okay? It's not changing with time. And this this magnetostatics is actually the magnetic analog of electrostatics, wherein sa electrostatics, the charges are stationary, meaning they are not moving. So moving moving on, moving forward, so we recall that the basic problem of electrodynamics is let's say we have a collection of charges. We have Q1, Q2, and Q3. Okay, these are what we call source charges. And let's say we want to calculate the force they exert on some charge Q. Okay, we say on a test charge Q. And we can do this by virtue of superposition principle, wherein if we want to find the total force exerted by these source charges on test charge Q, all we have to do is calculate the individual force that is contributed by each charges. Okay, so we have to sum all of those. So when we say superposition principle, we just have to calculate the force contribution by Q1, okay, turning off all of the other charges. Next is we turn on Q2 and turn off the rest, and so on. So that's the superposition principle. So to get the total, we just have to sum all those individual contribution. Let me so nana siya you have F total F1 due to charge Q1 plus F2 and so on Fn. So that is according to the superposition principle. So it is sufficient to find the force of a single source charge. The total is then the vector sum of all the individual forces. Now, up to this point, we have confined our attention to the simplest case, that is electrostatics, in which the source charge is at rest. Okay? At rest na siya, although the test charge may not be. So this time, we will now consider forces between charges which are in motion. Okay? So if you have charges in motion, you create now what we call current. And once you have current, you create what we call magnetic field. Okay? So consider this scenario. Let's say we hang a wire onto the ceiling and separated a few centimeters apart. Can you see here? You have two wires and it's connected by a battery in this case. So when you turn on the battery, okay, you connect these two wires. You have the positive side of the terminal and the negative side of the terminal. Connect mo ang wires diha. So once connected na siya, current will flow. So take a look at the direction of the current here. On the left side of the wire, you have the current flowing upward, then current flowing downward sa right side nga wire. So as you can see in the figure, the two wires have opposite direction ang iyang current. And what we observe is that the wires will repel each other. Okay, so mo repel siya. So you might suppose, what causes or what explains this? Nganong mo repel man ang duha ka wires? Okay? So you might suppose that maybe the battery or whatever drives the current is actually charging up the wire. So if charging up the wire, so na charge, and that the force is simply due to the electrical repulsion of like charges. But this explanation is not correct. Okay? You can actually hold up a test charge near these two wires and there would be no force on it. That would be the case there. And in fact, these two wires are electrically neutral. It's true that the electrons are flowing down the line, that's what the current is, but the amount of charges flowing upward, the negative charge and the positive charge in the opposite direction, equal na sila in a particular segment. So technically, the wire is neutral. Okay. So moreover, I could hook up my demonstration as to make the currents flow in the same direction as you can see in figure B. Okay, so i-arrange mo siya in such a way that the wire will now, both of the wires will now have its current flowing in the same direction. So parallel na siya. Now the tendency for this case is they are found to attract. Okay, so attract siya. Unlike sa PICAS, ni repel siya. So whatever force accounts for the attraction of parallel currents and the repulsion of this anti-parallel, this we can say na dili gid na siya electrostatic in nature. So dili siya, it's all about electric field. But in fact, this is because of magnetic field. Ang iyang nature niya. Okay? So this is our first encounter of magnetic force. Okay? So this was observed through experiments during the time of Benjamin, during the time of Tesla, and so many other scientists that did the same experiments in the past. So whereas stationary charge produces only an electric field in the space around it, if we have a, let's say, positive charge, it produces an electric field. This is stationary na siya nga charge. If it's a negative charge, then the electric field will have this direction inwards here. So whereas a moving charge generates, in addition to electric field, you have magnetic field as well. In fact, magnetic fields are a lot easier to detect in practice. All you need is just a compass. So if you ask how this compass work, nganong makadetect man siya og magnetic field, that's irrelevant for the moment. It is enough to know for now that the needle points in direction of the local magnetic field. Okay, so ordinarily, kanang imuhang magnetic compass, mo point na siya sa magnetic north or the Earth's magnetic field. But in the laboratory, or kung if you are in a place wherein na ay local magnetic field na source, which is stronger man na siya compared sa magnetic field sa Earth. So the magnetic compass, ang needle niya, will always point to that local magnetic field, which is 100 times stronger than the Earth's magnetic field. So now if you try to hold up a tiny compass in the vicinity of the current carrying wire, you will notice that the field will not point toward the wire. It will not also point away from the wire, but rather it circles around the wire. So it yeah, somehow it behaves like this. So if you have a magnetic compass, ang imuhang magnetic needle will point this way, nana. So it will not, unlike electric field, it will point radially outward or radially inward. Okay, that's the case for the magnetic field. In fact, if you grab the wire with your right hand and the thumb is in the direction of the current, your fingers, your fingers will curl around in the direction of the field. Okay, so how can such a field lead to a force of attraction or repulsion? Okay, as what we've seen in the previous example in this figure, right? So as you can see, if you have wire 1, you have current flowing up, and the wire 2, we have the same current flowing upward in the same direction. Okay. So the second wire, the magnetic field points onto the page. Okay. If you curl ang imuhang gagamit ka aning right hand rule, actually the magnetic field points into the page or onto the page. And the velocity of the charges upward, and the resulting force is to the left because mo na itong ma-observe to experiment. Okay? It's pointing, so ang force is inward, so, or to the left. Now it's going to take a strange law to account for these directions, and we will introduce later. But our main concern right now is how do we calculate the magnetic field? Okay, magnetic field for the first wire maybe. So it may have occurred to you that the combination of these directions, take a look at the direction sa imong velocity sa current and direction sa magnetic field as well as the directions of force. So these directions, it's just right for a cross product, diba? Ang cross product is ano man na, we have A, if you have A cross B, the resulting vector is another vector and it's perpendicular with each other. So A is perpendicular sa B, perpendicular sa C. A pod is perpendicular sa C. So perpendicular with each other. Ano siya? So we have A perpendicular sa B, perpendicular sa C. It's like that. So the formula is like this. We have V cross B, perpendicular na sila. The resulting vector is another vector perpendicular to both. Okay, as seen in this diagram or picture. Now this is known as the Lorentz force. Okay. Now in the presence of both electric and magnetic fields, the net force on Q would be this one. Okay. So if you want to calculate the total force, that would be force due to electric field plus force due to magnetic field. We know the formula for the force due to electric field. We have QE. Then the force for the magnetic field, that's QV cross B. Okay, so common kay Q, you have E plus V cross B. That's why mo na siya. Now, we did not actually derive this equation, it is actually derived from the experiment. Na we have this relationship that the magnetic field is perpendicular sa current, direction sa velocity sa charge, and also with the force. So this is what we call equation phen through a phenomenon. This is what we call phenomenology. So phenomenological description of this system. So our main job from now on is to calculate electric field as well as the rules for as well as magnetic field. So for the rules are more complicated when the sources when the source charges are in motion. But before we proceed, it is worthwhile to take a closer look at the Lorentz force law itself. It is very peculiar and it leads to some truly bizarre particle trajectories. Take a look at this example. So take a look at this example one. You have a charged particle in a magnetic field. Okay, so if you have a charged particle moving upward and your magnetic field is pointing in the z direction or onto the page, the tendency is your particle, instead of moving straight because of the presence of this magnetic field, it will curve. Okay, it will curve this way, and somehow it will make a circular trajectory. Okay, but if wala na magnetic field, kaning particle nimo straight upward na siya. So, but because of this, but because of the presence of this magnetic field, so there is now a force, right? Katong force, magnetic force, which is V cross B. So the force is inward. So if you use your right hand rule, ang imuhang thumb is mo to siya ang direction sa current, and then ang imuhang magnetic field is if you use a right hand rule for this matter to get the force, ang imuhang upat ka finger should point the direction sa charge, and then imuhang i-curl ang imuhang upat ka finger towards the direction sa magnetic field. And ang imuhang thumb, that would be the direction of the force. Okay, in this direction. Inwards siya. So with the magnetic force, this magnetic force is actually providing the centripetal acceleration of the charged particle. So as you can see in this figure, you have a constant magnetic field pointing onto the page, and the charge Q moves counterclockwise with speed velocity V or velocity V or speed V, and around a circle of radius r, and the magnetic force is pointing inward, and for this case it has a fixed momentum. So how do we calculate for the momentum? So we have the force is just Q V cross B, since ang V cross B is perpendicular man siya, so that's actually QV sine 90, and sine 90 is just 1. So we have QVB, actually QVB sine 90, and sine 90 is 1, so that's why we have QVB. And this is equal to the Newton's law of Newton's second law, katong law of acceleration. So we have mv squared over r. Okay, we can somehow manipulate this one. We have mv times v over r. But this is mv is momentum, so m, as you have p dot v over r. This cancels on the left hand side. Tada. So momentum is just Q, inubra ang Q na. Q, B, R. Okay, so that's the momentum. Q is charge, right? And B is your magnetic field. So this equation is known as the cyclotron formula because it describes the motion of a particle in a cyclotron. So this is the first of the particle accelerator. Okay, it also suggests that if you have a simple experiment, you can determine the radius of its circular trajectory. So this means that we can determine the momentum of a certain particle given the radius na iyang i-make sa imuhang pag-move niya, and the magnetic field strength is known, so you can calculate the momentum of a certain particle. Okay, so incidentally, I assume that the charge moves in a plane perpendicular to magnetic field. Now what if it starts out with some additional speed parallel to B, okay, parallel to magnetic field, like the case sa kaning second figure. Okay, so if this is the case, if naa kay uh, parallel nga velocity component, what will happen is your particle will start to move in a helix fashion. Okay, helix ang iyang motion sa kanang case. Okay, and the radius sa helix is still given by this equation, but the velocity in question is now the component perpendicular to the magnetic field. Okay, so next example would be this one. This is a more exotic trajectory. Okay, this happens if, aside from the magnetic field, na kay contribution sa electric field. Okay, and at right angle na siya. So if you have magnetic field pointing in the x direction, the electric field is along the z direction. So let's say, suppose, so yun sa siya pag arrive that the motion of the particle is behaving this way, mo siya gbabuwar nga mo jump ana siya yung direction. So how does this happen? Okay, so let's think through it qualitatively first, and then later on we'll try to solve it quantitatively. So initially, the particle is at rest located at the origin. So in this case, magnetic force is zero because wala man nag-move ang imuhang particle. So recall your magnetic force, Q, V cross P. Ano imong electric force, Q, E. Okay? So initially, there is no magnetic force, but the electric field is naanay electric force, right? So this charged particle will tend to go up because of the presence of this electric field, so na electrostatic force, right? So this electric field will tend to accelerate the charge in the z direction upward, okay? So as the particle moves up, it picks up speed, so a magnetic force develops because of this equation. Na kay velocity, na kay direction sa magnetic field, so ang imong directions of force would be around in this direction, right? So instead of moving up permanently, but because ni develop na pud og magnetic force, so iyang bitaron ang particle para i-curve niya, right? I-curve niya in this way. So as it curves in this way, so the charge is actually pulled around because because magnetic force develops. Okay, so ni kusog po ang magnetic force. So magnetic force is stronger. Eventually, the particle curves back towards the y-axis. So the magnetic force again is zero. Okay, so velocity is zero. So in this case, ang electric force na pud kay mokusog na sad. Okay, so bringing the particle up, and as the particle moves up, magnetic force becomes stronger again. It curves downward the particle. So zero na pud ang magnetic force. So ang mo-dominate na pud diri is electric force, and so on. So the process repeats again and again. So mag-move na siya ginana, siya mo-hop. Okay? So the entire process commences anew, carrying the particle again from point A to B, from B to C, and so on. So that's why ang imuhang particle moves this way if you have both electric field and magnetic field in this direction. Now let's try to analyze this problem quantitatively. Okay, so um, we can see that in this case there is no force in the x direction, right? Ang forces is along the z direction lang and the y, right? So this is magnetic. Dito po sa taas, we have electric field or katong F electric. So we can actually determine and we can set or define the position of the particle at any time t it can be described by the vector, let's say r arrow. So this can be described by so you have x, y, z component. So wala siya x component ang iyang position, di ba? Naalaman siya sa y and z nga plane. So we have y of t, z of t. Now, we can then also define the velocity of the particle. Okay, we have r dot. So this is velocity. So this is 0, y dot, z dot. Okay. Now we can use this one. That's v cross b. So you have your v here. So let's try to determine v cross b. So cross product rule. So we have I, j, k. So ang components mong velocity, we have 0, y dot, z dot. We have components mong magnetic field is only along the x direction. So this would be b, 0, 0. Now, so performing the cross product. So starting with I hat, right? So cross ni siya, cross would na. So we have this one multiply minus this. It's actually 0 minus 0 minus the j hat component. So kanina po di mong i-crash out. So we have 0 minus b z dot plus K hat. So, kana pwede mong i-cross. So, you have 0 minus b by that. Okay? So, simplify this one. You get what? A positive this here. So, you have b z dot j hat minus b y dot k hat. Okay, so that's your v cross b. So we can now apply this one. We have magnetic force. So this is Q E plus B cross B. Diba? So this would be Q. So ang electric field is along the z-axis naman na siya. We have E K hat plus ang imuha da yung V cross B, which is BZ dot J hat minus BY dot K hat. Okay? Then, i-apply nimo ang Newton's second law, where F is equal to ma. So this would be ma. Okay? And ma is just acceleration sa particle. Take note that the acceleration of the particle is along the z and the y direction only. So you have y double dot j hat plus z double dot k hat. Okay, so this is equal to q e k hat plus b z dot j hat minus b y dot k hat. Okay. Now, next is we will try to treat the j hat and the k hat components separately. So we'll rewrite the equation. Yeah. So that's let's see. You have q e k hat plus bz dot j hat minus b y dot k hat. This is equal to m y double dot j hat plus c double dot k hat. Okay. So let's consider the y component or the j hat ato i-combine. So sa left hand side ang j hat component is kanina naman q b z dot is equal to sa right hand side ang j hat component is just m y double dot. Okay? For the z component, we have QE minus by dot is equal to m z double dot. Okay? So for convenience, we will let omega to be equal to QB over m. Okay? This is defined as the cyclotron frequency. Okay? So, imo siya i-substitute, ma-simplify nimo ang duha ka equation. So, you have QB over M is equal to QB over M C dot is equal to Y double dot. Or, Y double dot is just omega Z double dot. Z dot, I mean. Z dot. Ang PCAS food, you have QE over M minus okay equals z double dot, or we have z double dot is equal to, so kanina case um hmm, so pwede na to siya butangan og b over b, okay, para so parehara mo na sila. Para this one kaning cube b over m kaya mo siyang omega, right? So this becomes omega e over bm. Oh, wala na siya m. So di ana na siya. Minus okay. So kani siya no kulang pa dai kog q dinhi. So napa ni siya q, right? Okay, multiply man nimo siya you have q. Okay, so nani siya q diha. And you have omega y dot equals z double z double dot sa pikas naman siya. So kana. Okay. So simplifying that one, we have omega e over b minus y dot. Okay, so you have two equations here, this one and this. So that is actually a coupled differential equation, and we can solve this one by taking the derivative of the first to eliminate the z. Okay, let's do that. So take the derivative of y double dot. Okay, so mahimot ana siyang y triple dot equals omega z double dot. Okay, and your z double dot is given by this equation. So mo siya i-substitute. We have y triple dot equals omega times, this is omega squared na siya. Okay, so yung z double dot, you have omega. So we have e over b minus y dot. And ato siyang i-rearrange. You have y triple dot plus omega squared y dot equals omega squared e over b. Okay? So we can solve for y of t. Okay, itong buhaton is i-solve y of t. So we can do that by simplifying this equation, or ato siyang i-transform sa into lower order. Kay mas lisod man siya i-solve as is siya nga third order ni siya, third derivative. So we transform this down to second order. Kaya masayon mo siya i-solve ang second order. So we will define, say, I will define y dot to be m. So if you have y double dot, this would be m dot. So ang y triple dot is m double dot. So, ay mo equation mahimo na siyang m double dot plus omega squared m equals omega squared e over b. Now we can solve this equation using the existing method na pwede na siya ma-solve. Let's say through characteristic equation. Okay, let's rewrite this equation on the next page. We have m double dot plus omega squared m equals omega squared e over b. Mo ba? Okay. Now we can solve this equation using solve m using okay. We can solve it later if we assume first that the solution for this case is, ang solution niya is say m of t is composed of two parts. We have m complementary plus m particular. So, ang katong, if you want to solve this one, nasa duha ka parts. You have complementary or the homogeneous part and the non-homogeneous. Okay? So for MC, we set the right-hand side to be equal to 0. We have m double dot c plus omega squared mc equals 0. Okay? So we can use characteristic equation na yun for this case. To solve for MC. Okay, so we have r squared plus omega squared equals 0. Okay, mo na siya ang method sa characteristic equation, di ba? If we have second order na derivative, that would correspond to square. Then omega squared times, since wala man siya derivative, so that would be r to the 0 or just 1. So we have omega squared. Then, ang solution niya would be plus and minus I omega. Right? So if you have roots na imaginary, so ang solution sa imong MC would be some constant C1. So inani siya. Sinusoidal plus C2 sine omega t. So that would be the solution sa complementary nga part. How about sa particular nga part? For MP, we assume nga ang solution is equal to, say, some constant C3. Okay? So we can say nga, since constant naman siya kanin, this is constant, so we can assume nga ang particular part na solution is constant. So we can get MP to be 0 if derivative niyo mo siya. So ang MP double dot is 0 as well. Okay, so going back sa kani, so we have m double dot p plus omega squared mp equals omega squared e over b. So this is now 0, kaning double derivative niya. We are left with omega squared c3. mp is c3. This is equal to omega squared e over b. So c3 is just e over b. Or this is the solution sa m mo na mp, right? So, the general solution is mc plus mp. Ang mc is you have c1 cosine omega t plus c2 sine omega t plus e over b. Okay, so that's p over b. Take note nga kaning empty dili pa na siya mao ang katong original nga solution. Kaya nag-transform man ta. Take note that m is just y dot. Okay? So this is y dot. But we want y of t. See? So to do that, we convert this one. Y dot is just dy over dt. We can transpose dt sa right hand side. So we have dt, multiply everything by dt. Okay, and integrate. Okay, this becomes y equals, so the integral of cosine is negative, diba? Negative sign. That would be c1, oh, that's positive sign, I mean, over omega sine omega t. But the integral of sine is negative cosine, so minus c2 omega cosine omega t plus e over b t, kaya constant pa na siya, plus constant, another constant is a c3. So this would be the y of t na solution. This is y of t. Okay. So how about the z of t? Duha man ni siya. We have the y of t. We need to find y of t and the z of t. Ang y of t nakuha naman na to. Ang z of t, we can get it using this equation. So we need to take the derivative of y twice, and then we get omega z dot, then integrate z to get z in terms of something else. Okay, so let's rewrite this equation in the next slide. So recall that we have y of t equals, okay, we can simplify this further. C1 over omega is just C1 constant, and can C2 over negative omega or just negative C2 over omega is just positive C2, ay constant naman gihapon na, plus E over BT plus C3. C1 sine plus C2 so if you take the first derivative, you get omega C1 cosine omega t minus omega C2 sine omega t plus E over B. Okay? So taking the derivative again, the second derivative na siya, you get negative omega squared C1 sine omega t minus omega squared C2 cosine omega t. So kana siya. Okay? So mo siya i-substitute. Ito. Where y double dot is omega z dot. So this is omega z dot. Okay? So cancel ang omega kani sa both sides. So we have c dot equals negative omega c1 sine omega t minus omega c2 cosine omega t. So we can get z by dz. and then dt diha, integrate all over. So z becomes omega c1, o mawag ka na ng omega, just c1 cosine omega t minus c2 sine omega t. So we have z of t. So muna siya ang solution niya. Okay, so we have two solutions, z of t and y of t, which is kani. Okay. So next thing atong buhaton is we need to determine the constants C1, C2, and C3. Okay. So take note mo ni ang y of 1, mo ni ang c of t. So we can calculate or determine C1, C2, C3, and na pa rin siya constant. This is plus, this is C4. Right. We have C1, C2, C3, and C4 through the initial condition. We know nga the particle initially is at rest. So at rest man siya. So ang velocity along the y or velocity along the z at time t equals 0 is 0. So we can do that. So if we take the derivative of this, mo ni siya, di ba? And substitute time t equals 0. So we have 0 equals omega c1 plus e over b. So kanila siya gikan. Substitute t equals 0. You get this. Y dot is 0. Therefore, C1 is just negative E over omega B. Okay. Next is a Z dot. So if you take the derivative of this with respect to time and then equate it to 0, you get 0 equals, okay, so we have omega C1 sine omega t minus omega C2 cosine omega t. Okay. Then time t equals 0, so that's 0 equals so C2 is just 0. Okay. Another condition is ang position niya. This is velocity man, no? So ang position niya is 0 po, right at the origin. Na. So using this one, y of t and z of t, so we have 0 equals sa y of theta, so good. So this becomes C2 plus C3, right? But C2 is 0, therefore C3 is 0. Next is ang z of t, so we have 0 equals C1 plus C4. So C4 is negative C1. C1 is negative E over omega B. Therefore, ang C4 is positive E over omega B. So we have now determined the following constants, C1, C2, C3, and C4. So ang y of t would be negative E over omega B sine omega t. Niya ang C2 kay 0 man, ang C3 kay 0 po, we are just left with plus E over B t. Okay? Then, i-simplify niyo muna siya ang y of t. No more next one ginagawa. We have E over omega B. So we have omega t minus sine omega t. Na, then ang z of t would be, so this is negative E over omega B cosine omega t plus C4, where C4 is just E over omega B. Okay, so simplifying this one, factor out na ko ang E over omega B. We have 1 minus cosine omega t. Okay, so we have this equation and this equation. Okay, so we can somehow simplify this one para ma-eliminate na to ang sine omega t o cosine omega t. Ako siya i-transform. So, recall ang y of t is just E over omega b omega t minus sine omega t. Kumana, di ba? Tara, kani. So, I'll transform this one in such a way na, okay, but before that, let us define first, okay, ato i-define this one. E over omega b is just r. So we have r. So we have r is E over omega b. So this is omega t minus sine omega t. So ako siyang i-transpose. So kani siya r sine omega t equals, ako siyang ibalhin sa left hand side. So ang right hand side mahimong mahimong have r omega t minus y. Okay? Then sa z pod na part, so sa z of t, we have E over omega b, 1 minus cosine omega t. This would be r, 1 minus cosine omega t. So the same thing gihapon ako ibalhin. So we have r cosine omega t is equal to r minus c. Okay, so r minus z na siya. So if I square this one, ako siya ibalhin. So we have r sine omega t is equal to, actually pwede na ako siya ibalhin. We have y minus r omega t. The same naman na, diba? And ang pkas, we have r cosine omega t. That would be negative z minus r. If I square both sides, kanipod is square. I-add na ako na siya na ma-simplify ang equation. Should be able to get r squared. So we have sine squared omega t plus cosine squared omega t equals, square din mo na siya, mawag na negative. So you have y minus r omega t squared plus z minus r squared. Take note, sine squared plus cosine squared equals 1. That would be, ako siya, no? It would be y minus r omega t squared plus z minus r squared is equal to r squared. Now this is familiar because that is actually the equation of a circle. Okay? So, wala to na-notice. So, it comes as a no surprise for us na ang iyahang path or trajectory is of a circle, right? If you recall sa ato ang equation sa y o z, it involves sine and cosine, so sinusoidal siya. Because mao man siya ang path, di ba? We explained this already qualitatively, nganong inanay ang iyahang path because of the forces sa electric field and magnetic field. And quantitatively, ang path niya follows this equation. You have y and z. You have y and z. Or simplifying, we get this equation of a circle. So this is an equation of a circle whose center at 0 ang x, ang y nimo is r omega t, ang z is r. Okay? And it travels in the y direction at constant speed. Ang speed niya is sa imuhang angular velocity, we have omega r, where r is just e over omega v, ito na ang r atong gi-define. Or this is just e over b. So that's the constant speed sa imuhang particle. Okay? So the particle moves as though it were a spot on the rim of a wheel, rolling down the y-axis at constant speed v. And the curve generated in this way is called a cycloid. Is a cycloid. And notice that the overall motion is not in the direction of the electric field, as you might suppose, but it's actually perpendicular to it. Okay, so dito. Yeah. Okay, so dili lang sa tataman for our discussion. Next time or the next video, we'll discuss more on more examples sa magnetic field and why is it that magnetic force actually do no work. Then we have current and different current densities. Okay, so for now this ends our discussion on magnetic field, and see you on the next video.